Today we're going to continue filling out the unit circle. So last time we used SOHCAHTOA, so hopefully everyone who was here is solid on how we figure out the coordinates of all those points. Now, I believe some of you guys mentioned it last time. Someone over here, I think, found one of the patterns. There are patterns with how these coordinates are written. So you don't actually have to do right triangle trig every time to figure those out. You can follow a pattern instead. So I want you to turn to your neighbor and tell them a pattern you see with the coordinates of those 3 points. Tyler, did you get this worksheet? It needs to be out on your desk then. This worksheet needs to be on your desk. Well, then come get this. I've passed them out to other people. Okay, let's actually turn the other way. Turn to a different neighbor, go in the other direction. And tell them your discoveries of a pattern. Paula, were you here last time? You were? Okay. Just don't remember. Okay, let's hear some. Everyone turn forward, please. Okay, Amy, pick someone in the room, please, to tell us what they've observed. Styles. What do you mean by opposite? Okay, we're not focusing on the 1, 0, it's just these 3 coordinates. Okay, so you're saying the 30-degree angle is reverse of the 60-degree angle. Okay, cool. That is an observation. So let's pick someone else over here on this side of the room. What? Okay, at least one of the point, in each point there's at least one term with a square root. Square root, square root. Okay, good. That's another observation. Pick someone else, please. Okay, Arbor. Okay. Oh, that's, yes, the 45-degree, the cosine and the sine are the same, right? Cosine and sine are the same, root 2 over 2. Okay, there's still 2 observations I have not heard yet. I think we talked about them last time. Noah? That's, okay, on the x it's going 3, 2, 1, and then on the y it's going 1, 2, 3. What is the square root of 1? What's the square root of 1, Ariana? What's the square root of 1? It is 1. That's why 1 is the only one without the square root sign. Because this is really square root of 1, square root of 2, square root of 3. But since square root of 1 is just 1, we don't need to write it. So there's definitely a pattern. If you can start in the top left, you go 1, root 2, root 3. 1, root 2, root 3. There's a pattern. Okay, there's one other observation I think we mentioned last time we haven't said yet. M?
So, I actually picked this up considering yesterday, but the quadrant over here, like the upper quadrant over here is positive, positive. The one over here is negative, positive. The one below that is negative, negative, and the one over there is negative.
Yes. Good. We're going to use those signs today when we actually go through the whole thing. What do they all have in the denominator? They're all divided by 2. So we're going to actually go with what M just said, and we're going to go around the circle and fill in all the rest. So we're going to move over to quadrant 2. Grab your pencil. This one's 240, and then the straight down, the 0, -1 is 270. Okay, So grab your pencil. Let's write in our values all the way around. Do you not have this? Okay. The important thing is to think of like a fan. Okay, Danny, make sure you're looking this way. Okay, this 60 degree right here is nearest to our 120 degree, right? So those two are going to match. That's where we start. 60 degrees had 1/2 first, and so we can just follow the pattern. First, let's divide by 2 on all of them, fill those in, and then we'll just follow in a circular motion, 1 root 2 root 3, 1 root 2 root 3. So in a circular motion, starting on the top left, we go 1 root 2 root 3. Circle around, starting on the bottom, 1 root 2 root 3. Does that make sense? Now, M mentioned there's a difference of signs. Okay? M, what do we know about the signs in the second quadrant?
X is negative and Y is positive.
Great. Because right here, do you agree with her that the x-axis is negative? Do you agree with her? Yeah. So, and then up the y-axis is all positives. So, I don't know if I can get that to go away. It's not going to go away. Okay, so we just need to go throw in a negative sign in front of all the x coordinates. Now we're going to rotate around to the third quadrant. Again, think of a fan. So this guy's on the inside. Let's fill in. First thing I do is fill in everything with over 2, over 2. Oh, sorry. Better? Okay, I find my top left piece by seeing what's closest to it. The inside coordinates are x, oops, oh my goodness. Our x is root 3. So starting on the top left, root 3, we go in order. Root 2, 1. Circle around on the bottom. Root 3, root 2, 1. If you notice, root 2 over 2, root 2 over 2 always is the middle one. Just signs change. Okay, Gentry, what are the signs of the x-coordinate in the third quadrant? What? Negative. Good. So we need negative signs. Chivs, what's the sign of the y-coordinate in the third quadrant? Yeah, the y-axis right here. Going down. What type of numbers are those? Also negative. So both x's and y's are negative in this quadrant. Remember on your test, you'll be given basically a blank unit circle, and you have to go through and fill it out.
Is that all I tested?
No, there's more to it. So if you can see a pattern, it helps a lot. Okay, last quadrant, first thing, put it over 2. Put every piece over 2. Okay, I start first by finding what was closest. Think of a fan spreading out, so the inside angles are going to match up. So we have 1, then go up, root 2, root 3, circle around, 1, root 2, root 3. And you can see that this inside one matches the inside one there. We just have to worry about the signs. So those should always match. The inside should always match. Okay, D, what's the sign of the x-coordinate in the fourth quadrant? What's the sign of the x's? Here's our... It's not your turn to answer. This is for D. Okay, D, what's the sign of the y's in the fourth quadrant? Negative. So the y's are the only ones we have to go through and put a little negative sign. Any questions on that? Not filling out a unit circle, but I bet you there are some questions about the, you could see a question on the ACT that says, like, what is the cosine of 150 degrees? So which one's cosine? The first one or second one? It would be the first one, alphabetical order. Oops, this got erased somehow. Cosine theta. So then you could do negative root 3 over 2, whip out just that quadrant, and do negative 3 root 2. A little bit. Once we work with them enough, you'll get much better at them. When you take college algebra, it's 1060. You use these a lot. So like next year, you could take 1050, 1060 for math. Math 1050 is college algebra, and then math 1060 is trig. Yeah, so that's a semester class. So if you take 1050 in the fall, then you would probably take 1060 in the spring. And you'll be using these a lot more than we will this year. A lot more in depth. Okay, great. Now we've filled in everything around our unit circle except for there's one line on every angle we haven't filled out. Will you grab, please, a new piece of paper and title it for our notes for today the following. I'm going to come around and give you this little pipe cleaner. Don't lose it, please. Take one and pass them back. Good. You can use that then. Okay, set up your notes, please. Take a pipe cleaner and pass it back. Whew, I barely need enough. I have 2 extras.
Barely enough. Oh, now I did.
Did you pass them back? Or did I gave it to him? Okay. You guys who are socially in the back, I can tell you're not setting up your notes. Our title for today is called Radians. Essential question. What is a radian? Be specific. And how do you convert back and forth between radians and degrees? That's what the last line on our unit circle is. Remember last time we talked about there are 2 different modes on your calculator. The mode we have worked with so far has been the degree mode. What was the other mode that was on our calculators? Radians. So today we're going to learn what in the world a radian is. You know, that's a very good point. Radius is half of the diameter. Radian has a relationship to the radius, but it's different. That's a very good point. So, I've given you a pipe cleaner. I'm going to come back to this unit circle. You should still have your unit circle out on your desk. I would like you, if you notice, your pipe cleaner, I've tried to cut it to the size of a radius, because it is related. So if you measure, it should be pretty close to your radius. What I'd like you to do is take your pipe cleaner, which is the length of one radius, and bend it around the outside of the circle, and what you're trying to do is calculate approximately how many radii it takes to bend around the circle. Okay. Okay, so we're getting decimals. Great. 6.5, 6.4. What else are you coming up? 6.2. 6.1, 6.11. Austin, what do you think? Exactly 6, okay? Yeah, it's probably because I just cut it a little too long. So it's sounding pretty much like we're getting, how many radii go around the outside circle? It's between 6 and 6.5. Maybe equal. R is your radii. So that's mathematical notation for how you would write radii, or radius is between 6 to 6.5 times around the circle. So, if I raise a hand, please don't shout this out. I keep saying around the circle. What are we actually measuring? There's a vocabulary word for around the circle. Please raise your hand if you know it. Yes, Silver? Okay, perimeter, yes. But for circle, we actually have a special word that does mean perimeter. Austin? Circumference. Remember that? Let's write circumference down. Oops, I'm missing my bar. Circumference. Circumference has a formula which oftentimes people, even myself, it took me a while to get these down, got area of a circle and circumference of a circle formulas confused. So what I did to remember which was which, I just remember area is 2 dimensions and it's squared. Your units are always feet squared, centimeters squared. So area is pi r squared. It has the squared in it. Okay, there is a hand who can tell me what circumference formula is. If area is the pi r squared, who has the circumference formula? It's not cube, that would be volume. Because circumference is actually just walking one direction around the circle, so it's actually in one dimensions. It is pi times something. We're getting warm. Gentry, are you raising your hand? Oh, I thought it was a little wave. How many R's? 2R. Pi times 2R. Or we say 2 pi R. Does that sound familiar? 2 pi R. 2 radii is the same as 1 diameter, so you could also say pi d. Okay, I need everyone to come get your calculators, please. Calculators, please. You're supposed to get those at the beginning of class. Please come get them. Okay, so we're going to find the circumference of our unit circle. We talked last time what the word unit means in length. Okay, notice unit is singular, it's not plural. So on our unit circle, please show me with your fingers in the air, what is the length of the radius of the unit circle? Please show me with your fingers in the air. Thank you. Awesome, people are remembering. The length of the radius of a unit circle, knowing that unit is singular, so it would be, good, we got it, 1, excellent. So we can find the circumference because we know that the radius is 1. 2 pi times 1 is just 2 pi. So I'd like you to calculate for me what is the value of 2 pi. What is the value of 2 pi? 2 times pi. 2 times pi. Calculate it, please. Everyone remember where the pi button is? It's right above the caret. You have to hit second caret. Benito, did you get it? Approximately 6.28. Okay, that's 2 pi's. How much was 1 pi? Approximately 3.14. So 2 pi's is 6.28. So the circumference of our circle is 6.28. So what is a radian then? A radian is the number of radii required to wrap around the outside of the circle, which is the circumference. Outside or circumference of the circle. The number of radii required to wrap around the outside or the circumference of the circle. So how many little pipe cleaners did you say it took to get around the circle?
6.5.
So we got 6.5, we got 6.4, we got 6, and we got 6.2 was our closest one. So good. You guys, just based off of how I cut it, I could have cut it a little too long or a little too short. That was my fault. But essentially, we got pretty close to 6.28. Okay, so no matter what the radius was, if our radius was 10 feet long, it's a pretty big circle, it would take 6.28 of the 10 feet radii to wrap around the circle. Does that make sense? A little bit. If our circle had a radius of 10 feet, no matter what the circle is, it would take 1, 2, 3, 4, 5, and I didn't do my radii very well, 6 and 0.28 of a radius to wrap around. To go around the circumference. Always, no matter what the circle's radius is, or how big, how small the radius is. We'll always take 6.28. 6.28 radii, yeah. Okay, so we're going to use that knowledge to fill in the last part of our unit circle. Okay, so we know in degree mode, one full rotation all the way around the circle in degree mode is 360 degrees, right? Yeah? Okay, you just discovered what one full rotation around the circle is in radians. What was it for the unit circle? Oops.
6.28.
Well, 6.28 is the decimal equivalent, but radian would be right here. Radian has the pi. So in radians, one full rotation is 2 pi. So 360 degrees is equivalent to 2 pi. So let's fill that in. Okay, I'm going to start with a 0 degree, would be 0 pi. Maybe blue might be better. 0 pi. And once we rotate all the way around, this lower line will be 2 pi. Okay, please fill in your unit circle. Now, if all the way around is 2 pi's, what's halfway around? 1 pi. If all the way around is 2, say you're in a pie eating contest, you eat 2 and your neighbor eats 1, they've only eaten half as much as you, right? So this would be 1 pi. Yeah, I'm not actually a huge pie fan. There's only very select few pies that I like. Okay. Okay, there's more to fill out. Now, if halfway 180 degree rotation is 1 pi, what's a 90 degree rotation, which is half of a half? Half of 1 pi would be 0.5, or we can say pi over 2. Pi halves. We use fractions. Yep. That's a good clarification. Okay, I'm waiting again for the same group. We don't write the decimals, we actually write them as fractions. So this would be pi halves. Now, we're going to write the 45 degree angle in radians, but what's half of a half? Arbor? 1/4. If you think in cooking, who's ever baked anything and used measuring cups ever in your life? Even in cooking class, yeah. Probably everyone. Okay? If, say, you need a 1/2 cup of flour, and you can't find your 1/2 cup, but you can find a 1/4 cup, it takes 2 4 cups to make 1/2, right? Do you agree? It takes 2 1/4 cups to make a 1/2. So, half of a 1/2 is just 1/4. So this would be pi fourths. Okay? There's one more we can fill in. Down here at 270 degrees. We know one full rotation was, actually, 180 degree rotation was 1 pi. Then we knew that 360 degrees was 2 pi. So what's halfway between 1 pi and 2 pi? Okay, you're getting really warm. How do we say the decimal 1.5 as an improper fraction? Heather, how do we say the decimal 1.5 is an improper fraction? Okay, let's do this. Everyone discuss with your neighbor, please. How do we turn 1.5 into an improper fraction? Because it is more than 1, but we write it as a fraction, so we're going to write it improper. Turn to your neighbor and discuss. Turn to your neighbor, guys. Nathan, Aiden, Noah. 1.5 is an improper fraction. Okay, who has figured it out? Raise a hand who figured it out. Okay, Styles, who's your partner? Okay, I hope you told them. Adam? What is 1.5 is an improper fraction? What? No, sorry, 1/12 is not. Ah, there we go, thank you. 3/2. 3 pi halves. 3/2. Yes, it was just not simplified. Okay, for all the other ones, we can use a formula to figure out, and then we can notice a pattern and rotate all the way through. So back to your notes. We have a formula to convert to radians. If it helps you know what a radian is, then please draw the circle. Convert to radian. To convert to radian, it's kind of like in chemistry class. Well, it is not kind of like, it is very similar to, where you're canceling out units. Don't you do that a lot in chemistry and physics? You line fractions up and you have to cancel units. Very important with radians as well. First, we start with our degree. So I need you to write the degree sign. That blank will be whatever our degree was. In order to change it to radians, we have to have the degree cancel out. So we're going to have to multiply by a fraction with degree on the bottom so that they would cancel out. Now the degree will multiply by, you can multiply by 2 pi over 360. However, because this is actually 1, 2 pi is equivalent to 360 degrees. 2 pi was 1 full rotation, and so was 360 degrees. However, this simplifies. So we don't, to save ourselves some trouble of simplifying, oops, what? We're just going to multiply by pi over 180. So we don't have to simplify it every single time. If you would, if you have a colored pen or a highlighter or just a really thick pencil and you can box this up, very important formula that you'll be using on your homework. And then we'll try an example. Example 1. The first degree we have on our unit circle we don't have a radian for yet is 30 degrees. Okay, so for example 1, we're going to practice convert 30 degrees to radians. Say what? that's where we're going to plug in 30 degrees. And this pi, by the way, the unit is radians. So this blank is where we plug in. So we're given 30 degrees, so we're going to plug that in. And we times that by pi radians over 180 degrees. It's very important to make sure you have a degree on the top and a degree on the bottom so that they will cancel. Any questions how I plugged in? Okay, so the degrees cancel. So show that you're canceling the unit. Also, I noticed, isn't 30 and 180 both multiples of 10? Yeah? So we can make our life a little easier. We don't need a calculator for this, so please don't touch your calculators. I can cancel out the zeros and think 3 divided by 18. But you please put up with your fingers in the air, what's the factor that divides into both 3 and 18? Put the factor, please, that divides into both 3 and 18. 3. Lots of people are showing me 6, which is nice, but 6 doesn't divide into 3. It divides into 18, but not into 3. What factor, so this factor has to be less than or equal to 3. It can't be any bigger than 3. What factor divides into 3 and 18? Thanks for showing me. So what'd you get, Cassie? 3, yeah? So, 3 divided by 3 is cancels. What's 18 divided by 3? 6. So we're left with pi on top over 6. Pi 6. That is the radian equivalent of 30 degrees. So if we go on our chart, go to your unit circle, please. And at 30 degrees, write in pi 6. Emmanuel, write that in, please. Zero pi. 0 pi, now we have pi 6, now we have pi 4, and we're going to solve for the 60 degree angle using the formula, and then we'll notice a pattern and we can go all the way through the circle. So example 2, convert 60 degrees 60 degrees to radians. Okay, I would like you to try that one on your own. Stand up when you have 60 degrees written as a radian. Using the formula, multiplying by pi over 180. Good.
Stand up.
Stand up, yep. Stretch break by standing. Yep. Good. Stand up and take a stretch break while we wait for everyone to finish. Good. 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 Okay. So what goes into 6 and 18? So 6 divided by 6 is 1, actually. So that just crosses out. And then what does 18 divided by 6 leave you with? 6, 12, 18. Great, okay. Yep, that's early. Okay. Yep. Okay, excellent. I think everyone I've seen has been right on, so have a seat. Thank you. So you already have this on your notes, but I'll fill it on mine. I like that I saw people actually doing the degree sign and canceling it out. And then to make our lives easier, we can cancel out the zeros. And what's the largest number, or our greatest factor that divides into 6 and 18? 3 is a factor, but not the largest. It would be 6. So that leaves you with pi thirds. Okay, so let's go on to our unit circle and fill in, please, pi thirds. Okay, please take note. At 30 degrees, what's the denominator in radians? 30 degrees. 6, pi 6. Okay, 30 degrees has the denominator of 6 in radians, so don't get us confused. 60 degrees has what denominator for the radians? Pi thirds. So they should not be matching. Okay, so we go pi 6, pi 4, pi thirds. So, would you agree that 30 degrees times 2 would be 60 degrees? It takes two 30-degree angles to make a 60-degree angle, yes? How many 30-degree angles does it take to make a 90-degree angle? How many 30-degree angles does it take to make a 90-degree angle? Tyler, I need you to be mentally engaged over here. It takes 3. So, we're going to use a pattern to go through and fill out the rest of the chart. You can do that formula every time to fill out the rest of the chart, but it'll take you a while. Or you can notice a pattern. Remember, you have to be able to fill one of these out by yourself. It's faster if you see the pattern. Waiting again for the same group. You guys have to stop. Okay, one 30-degree angle is 1 over 6, right? Okay, 2, ooh, don't want to do that. Sorry, squeals. Okay, this is really important. One 30-degree angle is pi over 6. A 60-degree angle is actually two 30-degree angles, right? So 2 pi over 6 is equivalent. Would you say 2 pi over 6 is equivalent to pi over 3? 2 6 simplifies to 1/3. Okay, so here is 1/6, here is 2 6, and then here is 3 6. Is 3 6 the same as 1/2? 3 divided by 6 simplifies to 1/2. Okay, now we're going to continue the pattern all the way through. So if that's 3 6, and the next one would be 4 6, but 4 6 simplifies. Yeah, 2 pi over 3. So fill in, that would be the 120-degree angle, 2 pi over 3. Because we have 1 6, 2 6, 2 divided by 6, they both are divisible by 2. 3 6, 3 divided by 6, they're both divisible by 3. 4 6, 4 divided by 6, they're both divisible by 2, which leaves you with 2/3. Does that make sense? Okay, let's keep going and see if as we go through it makes more sense. Okay, we're not doing the middle angle because that's a 45-degree, so we're skipping the middle one. This is 4 6. After 4 6, we would move then to add one more. 4 plus 1 makes it 5 pi 6. 5 pi 6. 5 pi 6. After 5, you add one more and you get 6 pi 6. Is 6 over 6 1? Yes. After 6 over 6, we then would move to 7 pi 6. After 7 pi 6, we get 8 pi 6. It's the even ones you have to be careful of because they simplify. 8 and 6, Ariana. 8, 6. What would that simplify to? 8 pi 6. Okay, what? It's not your turn. I'm asking her for a reason. Shh. I'm waiting again, please. Ariana, what divides into both 8 and 6? 4 does not divide into 6. 2. So 8 divided by 2 is 4, and 6 divided by 2 is, okay, 4 pi 6. Remember, we're skipping the middle one because that is the 45-degree angle. Oops, 6, not 3. Oh, sorry. It was a 3. 4 pi thirds, so I did it right the first time, and then I messed it up. Okay, 4 pi thirds. That was 8/6. After 8, we get 9/6. 9 and 6 are both divisible by 3. 9 divided by 3 gives you 3. 6 divided by 3 gives you 2. So 3/2. That's 9/6. After 9/6, we move to add 1. 9 plus 1. 10/6. But be careful on the even ones. 10/6 would be 5/3. 5/5. Danny? Start filling it in, please. After 10/6, add 1 more, and we're at 11/6. And then after 11, we add 1 more and get to 12/6. 12 divided by 6, would you agree that that is 2? Okay. Because it's a 45-degree angle. 30 plus 30 does not make 45. We're going to go fill in 45 in just like 2 seconds, so I'll let you finish filling that in. Okay, we're going, very last thing, and then we're nearly done. Let's fill in the 45 degrees. Same idea. Pi over 4. That's 1/4. What's 2/4? Because 45 plus 45 would make 90. So what's 2/4? 2 pi/4. That's why we have pi over 2 for the 90. After 2/4, we would then get 3/4. So we'll fill in this blank, 3 pi/4. 3 pi/4. After 3 pi/4, we then get 4 pi/4. And 4 divided by 4 is 1, correct? After 4 pi/4, Danny, I need you to sit all the way up, please. It's 5 pi/4. After 5 pi/4, we get 6 pi/4, which is this guy down here again. Because 6 and 4 are both divisible by 2, so it simplifies to 3/2. After 6 pi/4, we get how many fourths? After 6 comes 7 pi/4. 7, oh, my color changed, pi/4. After 7 pi/4, we have 8 pi/4, which is 2 pi. The unit circle is finally complete. Okay, the last formula you need is to convert to degrees. If you're given a radian, we'll just do 1 and then we're done. Convert to degrees. If you're given a radian, the formula is very similar to convert to degrees. Convert to degrees. If you're given a radian, to convert to degrees, again, you multiply by a fancy form of 1, but we need radians to cancel out. So the pi, radians, goes in the bottom, and pi is equivalent to 180 degrees. So the formulas are very similar, so please don't get confused. The key to setting it up is to make sure units are canceling. Box that up, please. All the way across. Those are the 2 formulas that you'll be using a lot on your homework. So if I gave you the radian 7 pi/6, convert 7 pi over 6 to degrees. Danny, you need to stand up. Stand up, please. Okay, 7 pi/6 is already a fraction, so we're going to keep the fraction and multiply by the fraction in our formula. Notice the pi is in the numerator, which means radians is in the numerator. So you have to have radians in the denominator when you're radians, so that they will cancel out. Noah, what's equivalent to 1 pi in degrees? That'd be 2 pi is 360 degrees. So 1 pi, 180 degrees, right? Okay, so you guys see how the pi's cancel out? The radians and the radians cancel out? I notice I don't have a zeros that cancel out, but I do see a 6 and an 18. Show me with your fingers what's the factor that divides into 6 and 18, the largest factor. Good, much better this time. 6 divided by 6 is 1. 180 divided by 6. Oh, what's that? 30. Oh, what in the world? My shadow like hits buttons or something. This new board is a lot more sensitive than last. Okay, yes, 30. So 7 times 30 tells us our degree would be 200. What's 7 times 3? 21. So 7 times 30 is 210 and needs a unit. What's the unit? Degrees. Take a look at your unit circle. That's 210 degrees. Is that really 7 pi 6? Look at your unit circle. Is 210 degrees really 7 pi 6? There you go. Okay, so last time you should have been working on unit circle problems and more about what else did it have besides unit circle? It has something else. Oh yeah, coterminal angles, things like that. I'm going to give you an extension on it so that now that you have more solid footing on unit circle, you should be able to easily answer those problems now. So this was the assignment from last time. If you're not done with it, then you have 2 more days. The new assignment from using the radians is page 397, numbers 1 through 4, 14 through 17, 19 through 22. Both of these, I actually prefer separate pages, I think. Yes, you did. Yes, you did have homework. Yes. It's a good thing you have an extension. So it looks like you have double the work. Okay, we will be correcting both next time.